Hello, welcome back. Let's solve Leetcode problem 74. Search a 2D matrix. Okay, so we have an m times n integer matrix, and each row is sorted in non-decreasing order, and the first integer of each row is greater than the last integer of the previous row. It means the matrix is sorted, uh, each row is sorted, and also each column is also sorted. Okay, so and we have an integer target. We need to return true if we can find the target in the given matrix, and false for otherwise. Okay, so this is a very simple problem, right? The knife approach that we can do is we will have two nested for loops, right? And then we will scan for the whole matrix. We can scan for each rows and also each column, and then we can able to find, we can able to check if the target exists in the matrix or not, right? So if do that, what is the time complexity? Well, the time complexity is m times n, right? Because we are scanning for every row and every column in two nested for loops. Okay, but for this question, the problem is asking us to have a solution in O of log m times n time complexity. Okay, so it means we only okay, so I think as the matrix had the property has the property is has the two properties are the rows is sorted in ascending order, and also the column is also sorted in ascending order. So we can think about another solution that we can think about another more effective solution. Okay. Okay, so let's check. For example, we have the target is 3, right? And then okay, so our approach is we will start from the end of from the end of the first row. We will start from the last column of the first row, start at this one, at this position, and then our rule is if let's write down, right? If the the value, I call it as the value, the value at current position is less than the target. Okay, it's less than the target. So what we do, well, if the current position is less than the target, so the only way that we can find for the target is we try to increase it, right? Try to increase it. It means we will what we do here, we will increase the row, right? And for otherwise we have to decrease the columns. Okay, so for example, if we are searching for 3, and then we start at this position, and then we check, we notice that 3 is less than 7. So the only way that we can search for 3 is from 7. We turn left, right? We turn left, and then we have 5, and then we notice that 3 is also less than 5. We will turn left again, and then now we and then we are seeing 3 here, which is the target that we are finding. Okay, let's check for another example. If I want to search for 30, and then I start at this position, right? And then I notice that 7 is less than 30, and then if the if the number 30 exists in this matrix, the only way that we can find it is we will try to check for the next rows, right? Because since the columns is sorted in ascending order, so we will go to the next row to find for the greater elements than the current position. Okay, and then again we will check. We have 20 is less than 30. It means if 30 is exists, it will appear in the next row, right? And then we have 60 is greater than 30, and then the only way that we can find for 30 is we go left, right? We check for the previous columns, and then 34 is greater than 30. Okay, so we go left again, and now we have 30 here. So for example, if I want to find for if my target is 19, okay, if my target is 19, it doesn't exist in this matrix, right? And then let's check if our algorithm is correct, right? We start at this position, so 7 is less than 19. Okay, so increase the rows. We will check for this row, and then 19 is less than 19 is 20 is greater than 19, and then we check for the left, right? Check for the left, and then 16 is less than 19, right? We will check for the next row. Okay, and 34 is greater than 19. Okay, check for the previous column. Okay, and 19 still less than 30, and then we check for the previous columns again, and 19 now is still less than 23, so we will go left again. So as we are out of the matrix, and we was unable to we are unable to find the target, so we will return false, right? We will return false. Okay, so that's it for the idea. Let's try to code it. Okay. Okay, so for the start row, I will start at the first row, and the start column I will start at the last column of the first row. It means matrix at 0 dot length -1, right? And y row is less than matrix dot length, and columns is greater than or equals to 0. Okay, so what we do, we will check if we will assign the current value to a variable. Value equal to matrix at row column if value equals to target. It means we can return true here, right? And if value is less than target, okay, if value is less than target, what we do, Okay, so let's check for target and value for better to understand. Okay, if target is less than value, we will check for the previous. We will check for the previous column, right? Column minus minus else row plus plus, right? And finally we can return false if we are unable to find the target. So that's it for the implementation. Okay, and let's try. Okay, looks good. Submit. Okay, accept. Oh, best performance. Perfect.